Are you studying for the CCIE Enterprise Infrastructure exam? Are you really confused by the software-defined components found in that test? Are you concerned about DNAC and SDA? Does the idea of implementing SD-WAN keep you awake at night? If that's the case, hang with me and I'm going to show you how, and we're going to start right now. All right, first and foremost, I want to talk about how my lab is currently configured because I'm using a virtual DNAC. That's going to be the Digital Network Architecture Center controller that's part of the Cisco configuration. Now, I want to illustrate that because I want everybody to understand what's involved in actually building one of these. So what I've got is I have my ESXi server, and I'm going to log in. And what I'm going to do is I'm going to take a look at this DNAC. If you want to run your own DNAC, it's perfectly possible to do as long as you keep in mind it's going to take a lot of resources. As you can see, I have a host here that is a server that is running two E5 2689 V3s. Yes, I would have liked to have had V4s, but I'm too cheap. And that's going to give me a total of 64 virtual CPUs since there's two of these. And as you can see, this device is actually running about 256 gigs of RAM. I created a virtual machine that is my DNAC. That virtual machine is running 56 virtual CPUs, 256 gigs of RAM, and it is running a 500 gigabit primary drive and two 1.5 terabyte drives. Now, the important thing to understand is that these drives should be solid state. I'm using a variety of NAND drives that are actually pretty quick, and to install the operating system, which is going to be the maglev operating system that is the DNAC's core, the system is actually going to scan these drives to make certain that they have ample read-write speed. If you guys are interested in the specific types of drives that I'm running, I'll go ahead and point that out if you ask for that in the comments. And what I basically wanted to do is I wanted everybody to understand that this is going to be the device that I'm going to be using moving forward. So I'm just going to log into it very quickly. This resource is not massively overburdened. Now, I actually tried to minimize the number of resources, trying to get this in as small a footprint as possible. I have successfully been able to run this DNAC using up to 48 vCPUs with 256 gigs of RAM and the same drive components. And this is the way that I'm actually going to be doing it moving forward. Now, what I want to do is I want to actually access this DNAC. So I'm going to access the DNAC, which is located at 100.64.0.101. So from here, I'm going to log in, admin, ISE is cool, and this should allow me to access the graphical user interface. Now, things that I want to verify here before I move forward. First of all, I want to make certain that I am running 1339. Secondary to that, I want to make certain that I am running all of the most recent updates. So what I'm going to do is I'm going to hit software updates and go to software updates. And we see here that everything is up to date for 1339. If I wanted to go to the newest version, which is 2125, I could simply do that here. And then that's going to force me to go through a series of upgrades. But keep in mind, we're talking about the enterprise infrastructure exam. And as such, I want you guys to stay in the 133X range because that means the graphical user interface is going to be one-to-one to what you're going to see in the lab. The next thing that I want to verify is I want to go to the provision section and I want to ensure that the Fabric tab is present. In some updates, I've run into issues running this in virtualization where I've installed the software and the Fabric tab has not appeared, and that's going to cause us problems when we try to go in and start labbing. And the Fabric tab is going to be pivotal to actually building the infrastructure that we're going to be using for the purposes of looking at the different types of technologies that are involved in the DNAC. Now, as a direct result of this, if it doesn't appear, a lot of times I just simply reload the device and it does show up. Sometimes there's a update that's hung, and as a direct result of that, you're going to need to kill one of the containers and bring up the offending container a second time. Sometimes you have to reinstall the software. My main process has been to get it exactly the way that I want it and then take a snapshot, and therefore it pretty much guarantees that everything will be reinstated when I revert my image between labs. The last thing that I want to check is going to be the fact that all of my services are running. So what I'm going to do is I'm actually going to click the gear tab here, and I'm going to go to System Settings. And what I want to see is I want to see that both assurance and automation are green. We're good to go. I see that all of my services are up and running. My software updates are all green, letting me know that I am where I need to be. And also, I want to note here that my ISE Engine integration has not been completed. The next verification is going to be taking a look at the ISE config. In my lab, my ISE server is located at 100.64.0.120. And I'm going to log in to this device using admin. ISE is cool. And this should present me with my ISE user screen. And what we're going to see in this configuration is this ISE config should not have the pxGRID services on. Let's verify this and make sure that is indeed the case. So in order to navigate to the pxGRID services, that persona needs to be activated. Another verification that I like to do is to actually SSH to the ISE engine itself and say show application status ISE and verify that none of the pxGRID services are in fact running or enabled. In fact, we see here that they're all disabled. In fact, a lot of the services that are part of this ISE engine are indeed disabled. Now, the first part of our lab, the first part of our engagement using these devices and resources is going to actually integrate the ISE engine with the DNAC. And there's a lot of theoretical components behind that, but I don't want that to become an issue. What I'm doing right now is I'm going to handle the integration. And then what I'll do is I'll talk about the theory behind that in a separate video set. The goal of this video is to demonstrate just how simple it is to actually create an SDA fabric. Now, once that's done, we will then obviously be concerned with things like onboarding endpoints, onboarding hosts, and things along those lines. But right now, all I want to do is take some of the fear and some of the concern out of this particular section of our lab. And in order to be able to do that, it's going to require us to actually integrate this ISE engine, which is going to provide us the identity services functionality, as well as micro-segmentation capability through the distribution of our scalable group tags, or SGTs, and the DNAC, which is going to be the orchestrator that's actually going to take control of the devices and the resources that are going to be part of my SDA fabric. So let's take this step by step, and we're going to begin with the integration of the ISE engine and the DNAC. Now, in the CCIE Enterprise Infrastructure exam, this is not something that you're probably going to end up having to do. In fact, it's my understanding that you're really not going to interact directly with the ISE engine itself. So it's safe to assume that it's probably going to be configured for you. And if not, I'm walking through the process, especially since you're going to probably want to build your own lab or work with mine, and integrating the ISE engine to the DNAC infrastructure is going to be your job in class, or if you actually take a rack rental. Now, this process is not complex, but we do want to make certain that we enable the features that we're going to need to allow this to work. Now, what I'm going to do is I'm going to go ahead and enable a number of features. We see monitoring is currently on. When I go to policy service functionality, what we're going to do is I'm actually going to make certain that these two tabs are activated: enable session services and enable profile service. I'm also going to want to enable SXP. That is going to be the SGT Exchange Protocol Service. We may look at that moving forward. In the lab, SXP is not called out as a protocol that you're going to need specifically. However, understand that it may be necessary to run SXP in order to be able to ensure that your micro-segmentation SGT information can be exchanged between fabric sites. Ancillary to that, I'm also going to enable the device admin service, and what that's going to do is that's going to activate TACACS. Also, bear in mind, I'm going to enable the passive identity service, and I'm going to turn on pxGRID. I'm going to go ahead and hit save. And this is going to save these configurational settings. Now that this is saved, what we're going to do next is we're going to go back to administration. And from administration, we're going to go to system and settings. And what we're going to do is we're going to ensure that the ERS settings are the way we need them to be. This is my external RESTful service functionality. And what we're going to see here is notice the ERS is disabled. Now, what I'm going to do is I'm going to want to enable these services that are going to include the primary administration node. This is called our PAN. We'll discuss that in the theoretical portion. And I also want to make certain that I'm going to enable this for all other nodes. Bear in mind, we have an MNT node, we have a PSN node, and we have a PAN node, as well as a special purpose pxGRID functionality built into this platform. I'm going to go ahead and what I'm going to do is I'm going to hit save, and then I'm going to agree to continue. Now, while this is actually running and it's doing its thing, what I want to do is I want to revisit my ISE engine. I'm going to repeat my show command of show application status ISE. And what we see is the pxGRID service is currently still not running. I'm going to go to admin, pxGRID services, and let's see if the service is running. Now, it's in process of starting to come up, but what you're going to notice here is there's no connectivity to the pxGRID node. Now, the pxGRID node is the mechanism by which we're going to exchange information between the DNAC and the ISE engine. It's going to leverage a protocol called XMPP, Extensible Messaging and Presence Protocol. That service needs to be functional and operational before we can really proceed. Ultimately, what we're waiting for is we're waiting for this line to actually change from a red tab to a green tab telling me that XMPP is running. That's going to take some time. Okay, we can see that the Extensible Messaging Presence Protocol is indeed running now. And what I also want to do is I want to verify this from the ISE engine itself. So again, back to the secure shell connection, I'll hit enter for the show application status ISE. And we can see right now that our pxGRID services are now running. Now, the last configurational change that I want to make is going to be from the perspective of the pxGRID config on the ISE engine itself. And what I'm going to do is I'm going to go to settings, and under settings, I'm just going to go ahead and select automatically approve new certificate-based accounts and allow password-based account creation. I do not advise anybody to do this in production, but this is a lab, and I do not want to have to actually start rolling my own certificates. I want to take the path of least resistance for study. Lastly, let's go back over here and take a look at our config. I'm going to refresh, and what we're going to see is we have a number of client services. Notice that we have the MNT. We have the admin ISE engine. These are going to be representative of the PAN and the MNT node. Remember also we have the PSN that we're going to look at when we get to the theoretical conversation. Now, with this being done, my next set of configuration is going to actually be done from the perspective of the DNAC itself. Here we are on the DNAC. And if I scroll down, I'm going to see the externally connected systems widget. And inside of there, I have the no ISE server is configured. Well, obviously, we want to change that. So what I'm going to do is I'm going to go ahead and hit configure. And the DNAC is going to allow me to onboard a authentication and policy server. Now, what I'm going to do is I'm going to go over to the right-hand side here. I'm going to click the add button, and I'm going to simply add that device. It's located at 100.64.0.120, and it has that shared secret of ISE is cool. It is an ISE server, and as such, I'm going to tell the DNAC how to log into it using the credentials of admin and ISE is cool, and specify its fully qualified domain name, which is going to be ice.micronixlab.com. And I need to give this device a username, a subscriber name. To do that, I'm going to go ahead and put in DNAC, and I'm going to say 1.3.3.8 And I'm not going to specify an SSH key. I'm not going to specify a virtual IP address. I am, however, going to enable TACACS. Remember, we turned that on in the ISE engine. And now all I'm going to do is hit apply and allow this device to actually connect to the ISE engine. That's going to take a little while. We'll wait. What we see is what we're looking for. Notice that we have a connection to 100.64.0.120. I am employing both Radius and TACACS. The device that I'm connected to is an ISE engine, and my status is active. Now, what I want to do is I'm going to go back to the Identity Services engine, and what I want to do is I want to validate that the DNAC has actually registered with the ISE engine itself. We can see here the DNAC 1.3.3.8, the username that I created. And we can also see a registration coming from the DNAC NDP. That's going to be our network data platform. We'll discuss the different functions and different subsections of each of the individual controllers, meaning the DNAC and the ISE engine, in the theoretical discussion. But right now, judging from what I see here, my ISE engine has been successfully integrated with my DNAC. Now, from here, we need to look at the next part of the configuration, and the next part of the configuration is going to boil down to single-handedly the most important component when it comes to SDA and DNAC, and that's going to be design. Design is going to be where we access the controller and we express to the controller what our intent is, and we rely on the intent-based configurational mechanism baked into the controller to actually make that intent instantiated. This is the big difference between how we do things in traditional networking and how we do things in a software-defined infrastructure. In a traditional infrastructure, I access the device. It is imperative that I provide the configuration commands in order to be able to set the device up such that my intent, my infrastructure, my autonomous system, network, build, whatever it is I'm working on, comes into being. Inside of a software-defined mechanism, what I do is, rather than telling the controller how to accomplish it, device by device by device, what I do is I tell the device what my intent is based on my design, and then I hand that over to the orchestrator to implement and actually instantiate and make my desired outcome the actual outcome. From the perspective of our class, we have resources that we have to learn how to interact with and work with that exist in the control plane. And we use these resources to be able to express intent with regard to what we actually want to happen inside of our fabric. And we also know that we really and truly have three fundamental fabrics that we have to concern ourselves with. The first fabric that we contend, or that we concern ourselves with, I'm off the screen. Yeah, I hate that. Is what we call the SDA fabric. Now, this is more often than not referred to as the campus fabric. I think that's the very end of where I can draw, yeah. So this is the campus fabric. And we know that the campus fabric is going to be comprised of resources. We have the idea of our edge devices. We have the idea of our border devices. We can have more than one border device. And when we start looking at this, these resources would be what we call our border and our control plane nodes. These are obviously going to be our edge nodes. Now, I said something yesterday that has bugged me since I said it, and I just remembered that I wanted to mention that. And that was, as I was talking about device functionality. And and there was a question that was asked specifically about 9300s. And I think I said, and I just want to make certain that I correct what I think I said, whether it's actually what I said or not. I want to make certain that there's no margin for confusion for you guys that are going to go out and buy a lab or build stuff to build your own lab. I was talking about buying two 9300s. And I was talking about 3850s, and we were talking about using 3650s. Now, a 3650 can only function as an edge device. Now, a 3850 can function as a border, a control plane node, and an edge device, but not all at the same time. So in other words, what I'm saying is it does not support the feature set that we call Fabric in a Box. So if you wanted to build a lab and you did not want to use Fabric in a Box in that lab, and you just wanted to build an SDA Fabric that you could use your DNAC to control, 3850s are going to work for that role. And I get Fabric in a Box, all wound up in my brain. And the only devices that will do Fabric in a Box are going to be 93s, 94s, and 9500 Catalyst devices. You can't do it on an 8300. I'm sorry, on a 3800, 3850. But like I was saying, a 3850 can be a border node. It can be a control plane node. It can be a control plane border node simultaneously. It can be an edge node. So it's everything that you need. It just cannot do Fabric in a Box where you're running all of those functions and features on the same device. So I wanted to make that abundantly clear because I was, like I said, last night I was driving back from the doctor's office and I'm like, did I actually say that? Did I actually say that you couldn't use a 3850 as a border node? And I really think I did. But what I meant to say is that you can't use a 3850 as an FIAB. So it can't be a control plane, edge, and a border node. So I just wanted to make certain that that was clear. Now, when we start looking at this fabric that we're dealing with, the fabric that we're actually implementing is going to end up being implemented from the perspective of our what I was calling our data center, or our ENT, our enterprise data center. And I just simply say that to delineate it from a Nexus data center. And what I really want to make certain that we talk about is going to be the tools that we use to implement and manage each of these resources. So first and foremost, we know that the device that we're going to use when it comes to SDA is going to be the DNAC. And we talked about the engines that are integrated into the DNAC. So we have a number of engines that are going to give us capabilities and features. And those engines include the NDP, which is the assurance engine. It includes the NCP, which is the automation engine. Now, please keep in mind, this is not all of the engines that are part of the DNAC. The other engine that is part of the DNAC, what I call it is I'm going to do it in a different color. So let me find my keyboard. I'm going to do this in yellow. The other engine that's actually built into the DNAC is called the integration engine. Now, the integration engine recognizes that the DNAC cannot be everything right now. In fact, it's not everything. But I expect the DNAC to start reaching out and swallowing up other functional engines in the infrastructure. And one engine that we also have to call our attention to that we're going to need is going to be this idea of the ISE engine. Now, I told you specifically in class, I think it was Monday, that the ISE engine is what we refer to as our policy engine. Now, the DNAC is made up of the NDP engine, the NCP engine, and as well as this integration engine. And the integration engine allows me to be able to integrate with things like a APIC from the ACI infrastructure. It gives me the capability of being able to integrate with, say, for instance, a vManage inside of a SD-WAN fabric. It gives me the capability of being able to integrate with the security engine, which is the ISE engine over here. So if we were to look at this from the perspective of resources, it would be safe to look at each of these elements as what we would refer to as functional nodes. Sometimes we could call these personas. And a persona, flip the S out, and a persona is basically just representing a set of functions. The NDP is going to be the assurance functions. The NCP is going to be the automation functions. Inside of the integration capability, I have the ability to be able to access other resources and work with them. So I could actually have this connected to an ACI fabric. I could actually have this connected to a SEN fabric. All from the perspective of the DNAC. Now, the other thing that we also need to understand here is that something is missing from all of these stacks that we described. And that thing that is missing is there is no, what I'll go ahead and dub a restriction engine. In other words, there is no construct inside of the DNAC that affords the DNAC the capability to say that two particular resources, two particular endpoints are not allowed to communicate with each other. In other words, what happens here is that I can implement this idea of segmentation inside of this engine. But we've already mentioned the fact that the only way that I can segment is on a macro level, meaning VNs and VRFs. Let me make that look better. Macro. So there's nothing in here that's going to say an endpoint connected here is restricted from communicating to an endpoint connected here as long as they're inside of the same VN. And that's not a good thing. And Cisco offers, and there are other vendors out there that offer the identity service engine functionality, what we call the ISE. But Cisco has their own, and it just so happens to be called ISE. And it too is made up of a number of engines. In fact, if I were to draw a single ISE device, a single ISE appliance, in this instance, what I would find is it's going to be made up of a number of engines. There is going to be something called a PAN, a PAN. That stands for a policy administration node. These are sometimes referred to as nodes, again, or personas. Now, I just borrowed the same terminology to reference the equivalent type in a DNAC, but we don't really call those nodes. We call them engines. But the thing is that what we're going to do is we want to be able to leverage this ISE engine as our policy engine because it gives me the capability of being able to implement things like SGTs, which offer me these restriction functions that don't exist natively inside of the DNAC. And as administrators, we're going to access the PAN and do all of the configurations. In other words, what we're going to do is we're going to log into the DNAC. I'm sorry, we're going to log into the ISE engine. And what we're going to do is we're actually going to implement what we will call, I'm going to call it my security grid. And the security grid is going to take a list of objects and a list of additional objects. And what it's going to do is it's going to give me the capability of being able to come over here and say, well, where are these two objects, the left side column and the right hand side column intersect, do not allow them to communicate. I could also come over here and say, I want this one, and let's say this one and this one to communicate. This is what we refer to as our policy grid. It's a grid because it's an indices, it's an index. And we create that by logging directly into the ISE engine, leverage the functionality of the policy administration node. And then what we do is we configure this. Now, obviously, ISE is a standalone construct. It doesn't necessarily have to exist in the context of DNAC. I can use ISE with ACI, APIC. I can use ISE without any of this. I can use ISE just for wireless. There's all kinds of options and features and capabilities that I have. Now, the thing that we need to pay attention to here is we've created this grid. And this grid is how we define the contracts associated with our scalable group tags. And that information is actually going to be communicated to another node inside of the ISE engine. And that is referred to as my PSN. And that stands for my policy service node. Honestly, at the end of the day, all the PSN is going to be a radius server or a TACAX server that is actually going to allow resources to connect to this PSN service and be assigned their SGTs, be placed in VNs, be assigned to VLANs, and everything that I need in order to be able to assure and implement that policy that we've been discussing. And what ends up happening here is this is all communicated from the PAN to the PSN. So that's where that grid is actually going to be enforced. And that's where resources that are going to have representation in that grid are actually going to learn that information. So as a result, what's going to end up happening is these devices down here, all the way down here in the fabric, are going to need to access the PSN in order to be able to learn the identity of the SGT, the scalable group tag that's being assigned to them, the VN if necessary. So I can actually build my fabric such that I could do things on a port by port basis. I can do things by an IP basis. I can do things by a fabric basis. There's all different types of options that we have in the context of SD-WAN. I'm sorry, SDA in this instance. There's also another engine that we have to pay attention to here inside of this configuration, and that's going to be the MNT engine. That's the monitoring and troubleshooting engine. The monitoring and troubleshooting engine is the engine that is actually going to take all of the reporting capacity and capability and capture it from all of these other devices and resources such that we as administrators can go in here and look at heuristic outputs, tables, charts, graphs, things that are going to give us an idea of what's happening the way we want it to, and obviously what's not happening the way we want it to in our infrastructure. This is our point of monitoring and troubleshooting. Now, there's also another functional construct that's part of the ISE engine, and I make reference to it as a node when I'm teaching, and this is what we refer to as the pxGRID node. Now, I've been using this word grid. For our purposes, I want you guys to think of this as the grid. So GRID, just like a grid, a graph, whatever you want to call it, is a grid, a matrix. And then we have this term of PX. Well, PX stands for Platform Exchange. So PX stands for Platform Exchange. Together, pxGRID is going to be my Platform Exchange Grid. So what is this? Well, this is actually a platform-independent protocol that I can use to communicate information. Specifically, the information that I'm going to communicate is information about this grid that we have built. And what ends up happening is I am wanting to create a relationship between the DNAC and the pxGRID node in the ISE engine such that I can actually communicate the grid information, what the grid is set up, how it's relative, what's permitted, what's not, and ensure that I have the ability to be able to patriate that information all the way over to the DNAC. So what's happening here is the DNAC is actually learning the pxGRID, all of that information. So I'll have that matrix. I'm going to have the contract that's going to be deny. I'm going to have all of those contracts that are going to be permitted. So, blah, blah, blah. And the beauty of this is now that that has been communicated, and now that this has been set up and established, keep in mind, this communication that's traveling between these two resources is actually bidirectional. So if I'm an administrator sitting here and I add something to the grid, that's obviously going to get communicated back to the ISE engine, and that same annotation will actually be communicated and represented here. Now, the reason that this is important is one, it sets it up such that I, as the network administrator of the DNAC and the associated fabric, I can actually make changes to the grid from the graphical user interface or the graphical user interface of the DNAC rather than having to interact with the ISE engine. And if I have an ISE engine that has been in service for, year or more, what I end up getting is the capability of being able to take all of this pre-existing grid information and communicate it to the DNAC. Now, there are a number of things that we need to make certain that we understand. pxGRID stands for the Platform Exchange Grid. By its very nature, it's designed to allow the DNAC to be able to pull contextual data as well as scalable group tags, SGTs, which are basically at the end of the day is just going to be labels like what we would be using in something like VMware. And what it's going to do is it's actually going to be able to understand all of the policies. Now, when I start talking about policies, what I'm talking about is SGACLs. The SGT is the tag. But the grid that I'm learning is going to be representative of what we actually refer to as the scalable group access control lists, or the ACLs, the permits, the denies, the greens versus the reds, and all of those components. And in the context of DNAC, SGACLs are policies, and they will basically allow who can and who cannot communicate, and that means specifically between hosts. Now, as a direct result of that, there are some things that we need to make certain that we understand. So first of all, pxGRID is a protocol that allows me to be able to exchange information, but it doesn't work on its own. It requires a couple of things. One of the things it requires is going to be XMPP. XMPP is how we get our platform independent mechanism. So I could take a Cisco proprietary solution and communicate using pxGRID to any other device, whether it's Cisco or not, the information associated to what's on the grid using extensible messaging and presence protocol, or XMPP. Now, there's also an issue here because of the fact that we want to make certain that we certify everything in these configurations so that we can securely obtain these connections. It has to be noted that we're actually going to need to use SSH. So over here on our ISE engine, we want to make certain that SSH is enabled because that's how the initial communications are going to take place. And SSH is obviously secure shell. And in order to be able to do that, we have to make certain that we have complement or agreement as it relates to our particular certificates and certificate authorities and everything along those lines. Another thing that oftentimes gets overlooked is an additional service called ERS. ERS stands for External RESTful Services. REST, representational state transfer, makes direct reference to the fact that devices and resources are actually going to be following a communication language that is going to approximate HTTP and HTTPS and XML action words: post, get, put, replace, things along those lines, delete. This is the language that we're going to speak. And we have to make certain that ERS is enabled on our ISE engine. Just understand that ultimately we want to be able to make API calls. Now, is this something for us as CCIE candidates to be concerned with? No, these API calls are going to take place underwater. Is bringing the ISE engine online and getting the ISE engine to actually do its job something that we as enterprise infrastructure candidates need to be concerned with? And the answer to that question is, again, no. However, is it possible that everything has been set up and then Cisco goes in and makes a change that's going to break the communication between these resources? So break this connection right here, causing pxGRID to fail? Yes, I think that it is possible. In fact, I think it's kind of likely. So with that being said, the thing that we've got to understand is that we as administrators are not going to be able to access the ISE. So either something is busted transit-wise between the two controllers, or something is going to end up being misconfigured on the DNAC. And if you're going to build your own lab, you're going to need to know how to do this. So what I want to be able to do is I wanted to be able to talk about the theory and the mechanism behind this so that we can understand what's happening. And also there's another element when it comes to setting up your own lab that's going to be very, very important for you. And that is going to be the fact that we're also going to have sitting in our infrastructure somewhere, we're going to have a DHCP server. So we'll have a DHCP server sitting out here, and that DHCP server is going to have to be configured such that it can successfully provide IP addresses to every device and resource in our infrastructure that is going to need that information. But we're not done right now. We're not done with this, because we need to talk a little bit more about these engines over here on the DNAC side. On the DNAC side, the NCP engine is the engine that I'm going to use to build my fabrics. Let me go ahead and minimize my pen size here. And the NCP is what I'm going to use to build this entire infrastructure from here to here. And remember, we called that our campus fabric. And everything that is adjacent to or functioning as an intermediate node inside of that blue cloud is going to end up being controlled from here. Also, it must be said that depending on how we built our fabric, remember, we said there were two ways that we could actually build the campus fabric. The campus fabric is going to be built in one of two ways. The first way is going to be what we call discovery. Discovery means that the underlay exists. All I'm going to do is identify devices that I want to be control plane nodes, border nodes, and edge nodes. The other way that we could actually implement this was through the utility of LAN Automation. And we talked about yesterday that if I use LAN Automation, I'm stuck with ISIS as my routing protocol, and I must allow the DNAC to handle the underlay. If I do discovery mode, the DNAC is going to handle the overlay and the devices that enable the overlay. Everything else is going to be handled old school with all the multi-touch points that we described earlier using CLI, or what we would call in the imperative configuration model. Now, with this being said, this is very important because, again, what we're doing is we need to understand what we're relying on to do what. And right now, as I said, we're relying on the NCP engine to configure this fabric. But the thing that we've got to also recognize is that in the same context, I meant to change the diameter of my pen, we also have resources that we are going to need to communicate to in our infrastructure. Specifically, I'm talking about to use the terminology of SD-WAN, sorry, SDA. These are going to be my fusion nodes. Now, these fusion nodes are going to be connected to my edge devices. In fact, it would probably be connected like this. If I had two fusion nodes, obviously they would be connected as like so. And bear in mind, we also mentioned the fact that these actually represent a separate fabric. So between these resources, I am going to have a fabric, and that fabric is going to end up being referred to as my transit fabric. But we also said that this transit fabric, I'll do a highlighter. We also said that this transit fabric is actually going to have a foot in both worlds. The service side VPN. So let's operate under the assumption that both of these devices are actually going to be vManaged. So these are going to be CEs. We'll say CE1 and CE2. And these devices are actually going to end up being vManaged. Now, what does that mean? Well, that means that they're going to be managed via my controllers that we've been talking about in the context of SD-WAN. So that means inside of here, I'm going to have a vManage. I'm going to have my vSmart. And I'm going to have my corresponding vBond. And again, I tried to drive home the point that based on connectivity requirements, I will first have to have a functional, I'll go ahead and just pretend that we have two transports on this guy. I must have a functional SEN fabric. So in this instance, I've got a third fabric in the middle here, which is my secure extensible network fabric. In other words, this is going to be my SD-WAN. And everything that this implies, we already know that in this particular instance, we should be running BGP down to these devices. Is it absolutely necessary that it be BGP? Not initially, but it will ultimately end up being BGP as we actually onboard the fabric, or as we go through and we do a LAN discovery. When we do that LAN discovery and when we do the automation, the system is going to say, oh, you've got these VNs that you created down here. Remember, we have VNs down here. We're going to have VRFs up here. And then those VRFs are actually going to map directly to VPNs in the SEN fabric. So when we start looking at this, this is what I was trying to say on day one when I talked about how everything in the CCIE Enterprise Infrastructure Lab goes hand in hand.